So we're gonna dive into word problems today. Word problems they can be difficult. So we've got a couple strategies that we can apply to help us solve these word problems. The main thing is we have to figure out what it's asking us to solve. If we don't understand what it's having us try to find, then we really can't get started. So that's the first thing. What is it having us trying to solve? And then what does it give us in the problem to help us solve that? Does it give us a distance? Does it give us a rate? Does it give us a time, for example? And then when I have those things, then I move on and say, okay, how can I approach this? Do I have an equation that will help me approach it? Is there some sort of visual that I remember that relates to it? And the biggest thing that I want you to try, especially at the high school level, is something. Even if you don't know what to do, don't stare at it, because in all my years of taking math, I've never stared at something and it magically appear on my sheet as the correct answer. So just try something, okay? And even if you get it wrong, I do award partial credit on tests, for example. So you just want to show me. There have been times, for example, when I've been in school and I didn't know what the heck this problem was saying. I didn't know what to do. But I wrote as much as I knew. And I told my teacher, I said, if I knew how to do the problem, this is what I would say to start with. But I'm not sure if it's right. And then I would keep going. Okay? So even if I got it wrong, the teacher at least knew what my thinking was. All right, so we're going to take a look at this problem together. You don't have to write all the words down. You could just write example 3, page 6, and then leave some space to write the process. You will have 1 or 2 word problems on your first test. They're not going to be too difficult. On the review day, we'll go over similar word problems so you're familiar with it and it's not a surprise to you when you see your first test. So it says, in 2012 Olympics, Usain Bolt, he's a track runner, won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter. So what are we trying to find? Average speed. What's another way we can write average speed? Well, that is an unknown, right? So what about a rate? Is that a rate? Speed is a rate. Okay, it's a rate at which you're going. You're going, 200 miles per hour. That's a rate at which your, race car is going, for example. So typically we write that as a rate. So the thing that we're missing is called a rate. So I'm going to write that down. I'm going to connect my Apple Pen. So I'm missing a rate. So my rate, I'm just going to call that R. What else in that problem do you think is important to solve it? Is anything in the first sentence important? 200 meters. 200 meters. That's a what? A distance. You ran 200 meters, right? So we have that. And it's 200 meters. What else is important? Yeah, 19.32 seconds. Audrey, put away your phone. There's a reason why you're sitting right next to me. Okay, so we have a time, and it's 19.32 seconds. So back in middle school, hopefully you went over a particular formula that related distance, rate, and time. Do you remember what that was? Yeah, D equals RT, or dirt, as I like to call it. D equals R times T. Distance equals rate times time. So we have a distance. What do we plug in for D?
200.
200, yes. Perfect, beautiful. We don't have an R, we have a T, so I'm going to plug in the 19.32. And how do I solve that? Divide. I divide, and then I divide. The other thing you want to do is pay attention to how they want you to round it. They say, find his average speed to the nearest hundredth of a meter. How many decimal places is hundredth?
2.
2. Right. So take 200 divided by 19.32, and you get an approximate answer. We denote approximate with those little wavy things. And so 10.35 meters per second. Yes?
If you're writing that and you didn't put the wavy lines, you just put equal signs, but you get it wrong.
You would lose half a point, yeah.
Because it's, what does that mean though?
So it means you're not giving the exact answer.
So you're
giving
close
an
to it.
yeah, you're giving an approximate answer.
Like an estimate?
Yeah, that's a great point, because anytime I ask you to round it, I'm looking for this sign.
So what do you know the exact, is there an exact answer or is there just...
There is, like, when you plug this in, you'll get a decimal, and if it doesn't stop going, your calculator's not going to display all of the decimals, right?
Yeah.
That's why we have rounding. So what is it actually equal to? 200 divided by 19.32. If we wanted an exact answer, we could just put that, 200 divided by 19.32.
Okay.
But I don't want you to write all the decimals, plus your calculator may not display all the decimals.
Right.
So that's why we ask for rounding. Does that make sense?
Yeah.
Okay, anyone else? That was a great question. Okay, great. Thank you so much. Or classwork. On January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to -4 at 9:27. That's a huge drop. How many degrees did the temperature fall? So we want to model this with an equation first. You can, of course, do it in your head, but we want to look at an equation that models it. So what's some important information?
The temperature.
The temperature. So we've got 54 degrees.
Yeah.
We've got -4 degrees. When it says how many degrees did the temperature fall, what kind of problem is it? Subtraction. So it started at 54 degrees. It dropped a certain amount. And by the end, it was -4 degrees. It dropped a certain amount in 7 minutes. So the time isn't really important, right?
Mm-hmm.
So
27 minutes?
in 7 minutes, or 27 minutes. Yeah, you're right. 27 minutes.
How do you know that?
It says it.
In the problem it says it. But it's not important information, right? So that's another thing that I'm glad the two of you brought up, because the temperature is important. The time isn't necessarily important, because it just wants to know how many degrees the temperature fell.
Yeah, but if it asks how long it took to also know that.
Right, yeah. So you have to understand what it's asking you. So how do I solve this? Subtract what?
You have to move, don't you have to cancel out the variable?
You don't want to
I
subtract.
mean, not the variable, the
54. The 54.
Oh, okay, well, big thing.
Very different, Audrey. Very different. But you were right with subtraction and canceling out.
I kind of just gave an answer, so it's like...
So you are trying though. I appreciate that.
Oh, I appreciate it. You're welcome.
So -4 minus 54. What happens when I take a negative and I subtract a number?
A positive.
Yep. Plus negative. So -58 degrees. So x equals, well, it's -x equals, positive 58. Perfect. So it says, this is a tricky one. My last couple classes had trouble with this last week, so we'll talk about this. It says, use the table to find the number of miles x you need to bike on Friday so that the mean number of miles biked per day is 5. So we're trying to look for the mean. What's mean mean?
Isn't it the same number? Wait, what is that mode?
Yeah, so
What?
average.
Mom, why are you in here?
I didn't say it. I said it.
Yeah, so it is average. Okay, so we're going to write that down. Mean is our average.
Then what's mode?
Mode is when you list numbers in order, what appears the most.
That's what
Well, you don't have to list in order. It's the number that appears the most. I think mode most. So we're looking at the mean, which is the average. Now, how do I find the average? Yeah, add them up and divide by how many there are. Right?
Do you divide them or should you divide them?
So I'm going to do step 1 first. Step 1 is to add them all up. 3.5, 5.5, 0, 5, and x. How many are there? Well, there's Monday, Tuesday, Wednesday, Thursday, Friday, so there's 5. What do I want the average to be? What does it say in the problem that I want the average to be? 5. It says it wants the mean number of miles biked to be 5. So I'm going to set that equal to 5. Okay, I've got a big fraction on one side. How do I get rid of that fraction?
Cancel it out.
How do I cancel it out?
Wait, is the fraction the
Well, I have something
3.5? Oh,
divided by something. So how do I cancel out that?
That's the fraction?
That's my fraction.
You
I multiply,
with
right? Because multiply is people. Dramatic. Okay, so we're multiplying on both sides by what number? By 5. By 5 and by 5. Does everybody understand that? Because if I multiply and divide at the same time, those are going to cancel out. Well, now I have all these things on top. I'm just going to combine my like terms. And when I combine my like terms, I get 14 plus the x still. And that's equal to now 5 times 5, because I multiplied by 5 over here. 5 times 5 is 25. And then, of course, what do I do?
Divide.
On this step?
Do the math. You add. You subtract.
If you're adding, yeah, you do the opposite. So if I'm adding, I want to do the opposite. Everybody with me? I know this is a challenging one. So you get 11. So the poor dude needs to bike 11 miles on Friday in order for his average to be 5 miles for the week. Questions on this? We've got one more problem to look at, and we will be done after that. No questions? Okay. When I think of a rectangle, I think of length and I think of width, right? We're all familiar with that, hopefully from middle school. So which is the longer side, the length or the width? The length and my width. Well, what important piece of information, or what pieces of information is important in this problem?
3 times the width.
Yeah, 3 times the width. So the length is 3 times the width. So whatever my length is, it's 3 times the width. Does that make sense? That's the key. Whatever my length is, it's 3 times the width. So
Are you ever use the area of rectangles?
no, you're just fine. So somebody asked me if we have to use the area of the rectangle. It doesn't ask for area. It just asks for the dimensions. So we just have to find the width and length. What other piece of information is important? It's 96 feet of fencing, correct?
And the dog.
No.
That's important.
Okay, shh, Audrey. All right, so now I'm going to take, I don't want to have width and length. So what can I replace L with to just have the same variable?
You can replace. Oh.
I want to hear from somebody over there. Okay, so what do I replace L with based on what I already wrote down? So I'm just working with W. Yes. 3W, right. So now I'm going to change this to a 3W and a 3W because of this piece. Does everybody understand that? So now I can combine like terms, and I can add this W and this W, which makes 2W, and then this W and this W, which makes 6W, and then I can combine both of them to get 8W, and I can set that equal to 96. Well, now, to solve this equation, what do I do?
We divide.
Yes. Yes.
Why can't you just, like, instead of making an equation of 2W plus 6W, why can't you just combine it all and make 8W?
You-
Skip that step.
So that's what, you can do that. You can skip that step, right? You can do that in your head. I just wanted to write that out for you so you could see that I'm combining the terms, combining the like terms. Does that make sense? So I just want you to know what I'm doing. So at this point, what do? Divide, yeah. divide. And so I get my width to be 12 feet. Remember the units. It's not 12 apples, it's 12 feet. So my length is 12 feet. How do I find, or my width is 12 feet. How do I find my length? Times it by 3 because of this. Does everybody understand that?
Yes.
Questions on that so far? So if my width is 12 feet, what's my length?
36.
36 feet. And that's it. Questions? All right, so let me give you your homework on the next slide. If you don't get done, 42 to 44.